Hi guys, so I'm welcoming you guys to another class of great impact. We want to continue looking at our structural drawings. So when we stopped in the last class, so we want to continue today. So as I've said earlier, as a surveyor, you have to be conversant with your drawings, and understanding drawing is very, very, very important. Just as the way you are executing your task on site. So it's very important to understand drawing too as well. Because it is when you understand drawing, that is when you know what to do. That is what tells you what you need to do. So you need to understand. So this legend, this general note area doesn't really concern us that much as a surveyor. So it's just description about concrete, iron, or whatever. So let's go to the one that concerns us. So mostly it's always starting from page 3. So if you remember the last class we had on um construction drawings for structural. So that one also starts from page 3. That was when we started from. So this one also, this page 3, as you can see on my screen. So the last one we did, which is on part 1 for the structural drawing, that project is all about a pad base, pad footing, and the columns coming out from it. So I said it that these designs is solely based on what uh, the soil test result looks like. That is the geographical area of that place. What suits that terrain, that soil, is what the structural guys used to use to do their design. But on this project that I'm showing you guys now, this one is another project entirely. So you can see here there is there are piles on that project. They introduce a lot of piles on that project. So definitely it's a water area. So this project is in Lagos State, Nigeria. So and you already know it's a water based place. You get so most of the projects in Lagos State, especially on the highland part of Lagos, is always piles. They always do piles there because of the terrain, how the place looks like. So you can see from this structural drawing, so we have some places that have circle. So those are the ones that indicate the pi position for the circle. So there are dimensions that connect those circles, or let me say as a reference from the grid line that you can always use to check the circle, to check the pi position. So that is that. And in between you see a rectangle shape. So that's a column. That's a column you can see of different angle, different shape rather. So I said it in the last class we had. The designer used something like red or is it brown to do his own column shape. So you can see that this one just uses another hash type to do his own shape. So here I think this is just for the pipes. This drawing is just showing us the pipe position and the grid lines too as well, that they can also use to confirm the pipes. So and the pipes are in different position, group of 2 here, group of 2 here, group of 3 here, group of 3 here, group of 2 here, group of 2 here. So you can see guys. So depending on the structure that is coming in that place, look at this one now. There are group of 6 pipes here. So we'll soon get to another page so that you will understand what I'm saying. So here, so this one talks about the length of the pipes that they construct, the depth rather of the pipes they construct. So this is the lift area. You can see the multiple pipes that are in that place because of the lift area. So let's go to the next page. Let's go to the next page. Okay, GA pipe setting now. So you can see guys that it is this drawing that the piling guys use to set out their pipes before they construct it. So most times it is surveyor too that give them the pipe position before they will start constructing them. So now let's get to the next page. So this one now, this one is saying pile layout, GA pile layout plan. So now with the pile, you can see a rectangle, a different shape that covers the pile. So this one now shows that there is a pile cap. that covers the two pipes, because that's how we do it. Once you have pipes, there's a pipe cap that must cover some set of pipes. So you can see the dimension. The designer have already fixed the dimension. This is 900 by 2.4, 0.9 by 2.4. So this one also is group of two. This one group of three. You can see that the shape is different. The one that has the group of three. This one also group of three. This one group of two. This one group of two. So that is that. Also with the same grid line as well. So you can see they have the pie cap, you have the column. You can see the column that is sitting down at the center of the pie cap itself. So it's well placed at position. So that is that. So you can see the lift area. This is the lift wall. This is the lift wall here. You can see the lift wall. Then the pie cap with it as well. So that is that. So this page is showing the pie cap section. So as a surveyor, so is either I requested for the AutoCAD format for this drawing so that I can superimpose them, and I'll be able to extract the point for the pie cap, so that I'll be able to set them out like this edge, this edge, this edge, this edge, this edge, this edge. So I'll be able to set everything out. And sometimes I might be the one, or myself and my team, that will just plot this out if we're unable to get the AutoCAD file, or I will convert this PDF to CAD file, which most likely some of them are not really accurate because of the way the format they use to design the PDF. So most times we always use to plot ourselves. So once we get a grid line, let's say for example grid line 8, so we just take the offset of this dimension to create grid line 7 to plot all the grid lines like that. Then we come to this axis to from grid line A, get the dimension, get that of B, C, D, then we now use it to plot all all the pie caps. So that is that. So as a surveyor, you need to look out for all the pie cap dimension. Make sure that when you are setting it out, they are the exact dimension you're supposed to have. Then you always check from grid lines to grid line if you are in order. So this next page shows the ground floor section, which is the ground beam and the columns. So you can see that they are using a black color to symbolize the column here. This one of C8, this one of C7. But the person that designed this drawing, the engineer, is supposed to have put the dimension of the column. I don't think they've done that since when we have been checking. I don't think so. I don't think so. Let me check. They've not. So I'm looking for a place where they dimension the column, because the if you remember the one we check in class in part one, so the designer, the structural engineer dimension the column. Here now, so they just give those columns a name, like a number, the C8, C7, C9, C9. So you have to go to a table. There must be a table that now explain the dimension for C8, for C9, and so and so on. So I hope we will see that in this drawing too as well. So this is a beam. There's a ground beam that connects the columns together. So you can see this beam one 600 by 225. So the depth is 600 while the width is 225. So that is for beam one. Let's check another beam. This beam two, the same dimension. So you can see here that 200 slab. So the thickness of the slab is 200 which is 0.2 meter. So you have to note that too as well when you are taking levels as a surveyor. So you have to note that too as well. So you can see here there's a beam of 750 by 600 by 225. So what this is actually saying is that this beam 10, there is an area where the depth of the beam is 750, and some area where the depth is 600. So you have to note that area as well. So I think it's the one that is in this lift area. That's where they will have that 750. Yeah. So there's a section that will show that. Which one again? So this is staircase. There's a staircase at this place. So you need to know that you can see the level. The structural guide is already indicating some levels, some difference in levels. So here is plus 150. Here is also plus 150. Here is also plus 150. There's a place I'm seeing 00. So here is 00. That means the other side we checked will be higher than this spot with 150 mm, which is 0.15. So as a surveyor, you have to take note of those things because they are very, very important. So this is column C5, column C3. So if I'm going to do this, I will just name all the column number, then I'll go and look for their dimension. So I'll be able to write it down and note it, and so that I'll be able to understand what I'm doing. So this is the ground floor plan. So there are two staircases, then one lift. So as I've said earlier, the lift area, it's always the foundation for the lift is always deeper than the rest of the foundation because there's always a lift shaft that's the lift operates from. So I hope we'll see that too. So this is what I'm saying. You can see the lift here, the pie cap for the lift. So this is the ground floor. This is the 00 section. This is plus 150 section. So you can see that the depth of the lift is different from the other depth of the building. So you can see they draw something like this. This is a void sign. So the lift used to have its own shaft. So that is that. So what else do we need to look out for? So which section is this? I think this is just okay. This ground. This is first floor plan. So you can see the column continues. So and there, so this is what I'm saying. As a surveyor too, you need to watch out for something like this because what here is saying is that there's a change in orientation for the column. Let's look at this grid line so that will indicate this column. This is grid line 7A. So let's look at it on the ground floor and let's look at the difference on this first floor. Grid line 7A. Let's go to ground floor to confirm that grid line 7A. So this grid line 7A, you can see the column. The column is facing this side. You can see now that the longer length for the column is facing this side on ground floor on grid line 7A. So let's check for first floor and see the difference. You can see that there is a change in orientation for the column. So you can see now that it has changed. So that's why the designer indicates it here. So the column has changed from this direction to this direction. So by the time I'm marking, by the time we want to, before we cast the slab for this first floor, I as a surveyor, I must have indicate this place, set out this new orientation for the column so that they will introduce, the engineer will now introduce another starter bar for that area. So those are the things a surveyor needs to look out for. So the same thing is happening here. Let me see if there's any other place. The same thing is also happening here. So you can see that there's a different color. He used white and another place black. So as a surveyor, you need to watch out. The same thing here. So that is that. I think that is that. So I said something in the other class too. So as a surveyor, you must also watch out for the beam section wherever the cut dimension for the beams because it is the beam that will help you to know the levels of your column you are casting. Once you know the height of floor to floor from ground floor to first floor, once you know the total height, so you will deduct the height of the beam from the total height. So that will now tell you the height of your column that you are casting because your column are the ones that is going to take the beam. So they must not be higher above where the beam is going to start from. So it is very, very, very important. You need to take note of that too as well. So I think that is that. That is that. So I think the next thing is just to check the height of the column too as well and understand what's really going on. So that's all, guys. That's all. So if there is any question or anything you see from the drawing that you think you really want to know more about, just drop the question in the comment section so I will attend to them. If there's any drawing that you think is giving you a tough time, just you can find a way to post it on the comment section so I will check and see how I can do any video on it. So you can see here too the column, there's a change in column on this side. So the column will change from bigger size to smaller size. The same thing here too as well. So that is all on that, guys. So I think we have covered much on structural. So In our next class, we'll be doing architectural drawing too as well. So we're going to look out the architectural drawing. What are the things we need to look out for as a surveyor? So we can always be in charge of our own job description. So see you guys later. See you in the next class. Cheers.